This is gonna blow your mind. Have you ever wondered why things move? Why a basketball bounces, a car drives, or a rocket soars into space? It's all thanks to the amazing world of physics. And today we're diving into one of the most important laws in physics, Newton's second law of motion. This law helps us understand how objects move when forces act upon them. Whether it's a giant rocket launching into orbit or a tiny ant carrying a crumb, Newton's second law explains it all. Get ready for a wild ride as we explore the fascinating connection between force, mass, and acceleration. Let's get started on this exciting scientific adventure. You need to hear this if you're a science enthusiast. Newton's second law of motion can be summed up with a simple equation. F equals ma. Don't let the letters scare you, it's actually quite straightforward. F stands for force, which is a push or a pull on an object. M represents mass, which is the amount of matter in an object. And A stands for acceleration, which is the rate at which an object's velocity changes. So what does this equation tell us? It means that the force applied to an object is directly proportional to its mass and acceleration. In other words, if you apply a larger force to an object, it will accelerate faster. Similarly, if an object has a larger mass, you'll need to apply a larger force to achieve the same acceleration. Now let's see how this works in action with a fun experiment. I bet you didn't know how simple it is to understand Newton's second law with just a toy car, some weights and a flat surface. For this experiment, you'll need a toy car, some weights like coins or small blocks, and a smooth, flat surface. First, place the toy car on the surface and give it a gentle push. Observe how far and how fast it travels. That's your baseline measurement. Now, let's add some weight to the car. Place a few coins or blocks on top of it. Give the car the same gentle push as before. What happens? You'll notice that the car doesn't travel as far or as fast. That's because you've increased its mass. And according to Newton's second law, you'll need a larger force to achieve the same acceleration. This simple experiment demonstrates the relationship between force, mass, and acceleration. The more massive the object, the more force is required to accelerate it, and the greater the force applied, the faster the object will accelerate. Are you fascinated by the power of rocket launches? Section 4. Real-world rockets, blasting off with Newton. Let's take our understanding of Newton's second law to a much larger scale, rocket launches. Imagine a giant rocket standing tall on the launch pad, ready to blast off into space. The rocket has tremendous mass, and to escape Earth's gravity, it needs an enormous amount of force. This force is generated by powerful rocket engines that burn fuel at an incredible rate. The burning fuel produces hot gases that are expelled out of the rocket's nozzles with tremendous force. This force, acting in the opposite direction of the escaping gases, propels the rocket upward. As the rocket ascends, it constantly burns fuel, decreasing its mass. With less mass to accelerate, the rocket's acceleration increases, allowing it to reach incredible speeds and escape Earth's gravitational pull. It's a spectacular example of Newton's second law in action. You need to hear this if you're a commuter. Section 5. Everyday examples from bikes to buses. Newton's second law isn't just about rockets and spaceships, it's all around us in our everyday lives. Think about riding a bicycle. When you pedal, you're applying force to the pedals, which in turn applies force to the wheels. This force causes the bicycle to accelerate and move forward. Similarly, when a bus driver steps on the gas pedal, the engine generates force that turns the wheels. The force from the wheels propels the bus forward, accelerating it from a standstill. The heavier the bus, with more passengers or cargo, the more force is required to accelerate it, just like our toy car experiment. These are just a few examples of how Newton's second law governs the motion of objects all around us, from the smallest particles to the largest celestial bodies. Section 6. Conclusion. This is why you need to keep exploring the science of motion. Newton's second law of motion is a fundamental principle that explains how objects move under the influence of forces. From toy cars to rockets, from bicycles to buses, this law is at work everywhere. By understanding the relationship between force, mass, and acceleration, we can better understand the world around us and the amazing science of motion. So, keep exploring, keep experimenting, and keep asking questions about the world around you. Science is all about discovery and wonder, and there's a whole universe of knowledge waiting to be unlocked.